Hello, now we are doing question 8 of the electromagnetism supplementary tutorial. In question 8 is one of the more challenging questions. It is also one of the more popular questions because it requires you to look at how an electron that is moving in a B field, in a magnetic field, how it behaves, and instead of it being moving perpendicular to the B field, it has also a component that is parallel to the B field. So if you look at this electron over here, right, it has two components. It has a velocity that is, so if you look at the velocity that's given to us, it has a component, right, that is parallel to the B field. Okay. It also has a component that is perpendicular to the B field. Okay. So what does this do for us? Right. So if we look at the electron from behind, right, what would we see? If we look at it from behind, what will we see? Well, we will see in this region of B field, right, where the B field is going into the pitch, right, the B field is moving away from us, so the B field is going into the pitch. Okay, we have an electron that is moving. Let's just pick this position. It seems to be moving up from this position. So let's use red to denote. Let's use green actually, because that's the perpendicular velocity, right? It's the velocity this way, and this v, let's draw it as a v perpendicular. Right, let's stick to better conventions. Let's call this v y. Okay, let's call this vy. Okay. So if we have a B field going into the page, the velocity of the electron being upwards, it's as if, using your left hand rule, it's as if there's a current downwards. Right? A velocity up for electron means that there is a conventional current downwards. Using your left hand rule, the field is into the page, the current points downwards off the page, your thumb points to the right. So you have a force. Maybe let me use, it's not the nice colors, it's yellow maybe. We have a force. Yellow's not very good. Let's use red. We have a force to the right on this charge. Okay, so from looking from behind, the charge experiences a force to the right. It will then turn and then move in a circle. Why is this so? Because at every point of the circle, it will experience a force that's perpendicular to its movement, pointing to the center of the circle. Okay, so here we remember the centripetal force is provided by the magnetic force. So we can say m v squared over r equals to b q v. And here, because we are looking from behind and we're looking at just a circle, the v here should be vy, the v here should be vy. Okay. So with this, we can cancel out, right? Vy cancels out with v squared over here. Then we can rearrange the equation to be r equals to mv, the y direction, over vq. Oh, over vq, not vy. Right. So if you look at So what happens then to the horizontal component here? Well, this means that this circle that is being traced out is moving deeper and deeper away from you. So I want you to imagine a circle, but it's moving deeper and deeper into the screen, away from you, right? If you look from the side, this is what we see, right? It's a circle that's being traced out straight, but it's moving further and further and further away from the eye. Okay, and that's what the horizontal component Vx does. It brings the charge further and further away from the eye. Okay, so if you look at the part A, explains the motions attributed to the vertical and horizontal component of the velocity which led to the helical path of the electron. Well, the vertical component Vy caused it to move in a circle. Vx causes the circle to move further and further away. Right, so it becomes a helical path. Right, if we look down at the official solutions, right, this is what is required of us. Right, it can be resolved in the vertical and horizontal components. Vertical component causes it to a circular path. Horizontal component causes it to move along the few lines further and further away. So these two effects together creates the helical path. Okay? Right. Part B, assuming that sine theta is 3/5 and cosine theta is 4/5, show that the velocity component of electron perpendicular to the B field is this value. That's not difficult. So the perpendicular component is just, the perpendicular component is just Vy. Something wrong. I can't seem to write over there. Let's write aside then. So let's look at the velocity again. So this is the velocity V. Theta. And we have given blue as the horizontal component. Something wrong here, so I will have to cut this video short and I'll come right back to fix this problem.